Okay, this is lesson 2 of kinematics, and we're still solving kinematic equations using the guess method. And we use the guess method just to provide you with a framework to approach these problems so that you can come to a solution. So I'm going to the physics classroom, and I'm going to cut and paste this physics problem to this PowerPoint presentation. I haven't worked this problem in advance, so go through my problem solving process in real time. Let's see how it goes. Okay, so it says a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. Okay, so first clue, starts from rest. And that tells us that our initial velocity equals 0 meters per second and accelerates uniformly over a time of 5.21 seconds. So our time equals 5.21 seconds. And for a distance of 110 meters, so delta x equals 110 meters. And determine the acceleration of the car. So our unknown is acceleration. Alright, so now we got 4 variables here. Initial velocity, time, distance, and acceleration. So which one of these best fits what we are trying to solve? So I'm thinking that this equation will actually work. Now we might have to rearrange it a little bit, but we have initial velocity. We have delta x. We know xi equals 0. And if you need clarification on why xi equals 0, check the last video because I explained that. And a is our unknown, and we have a time. So this is the winner right here. So let's go ahead and start with that equation. Delta x equals xi plus vi times t plus 1/2 at squared. Alright, let's make sure I write that down so I remember it. Okay, so what we want to do is get a by itself. So a is our unknown. So to solve for a, we need to get it by itself. And we can start doing that by subtracting these from the equation. So we're going to say delta x minus xi minus vit equals 1/2 at squared. Because if we subtract these from this side of the equation, they'll cancel out these over here. And anything we do to one side of the equation, we have to do to the other. So this is the other side of that equation. Okay? And so we still don't have a by itself. And so the first thing we need to get rid of is this 1/2. And the way we can get rid of that is by multiplying this by 2. This cancels that out, but we also have to multiply this by 2. Okay, so now this 1/2 is gone, this 2 is gone, and we have at squared. So a is still not by itself. We need to get rid of this t squared. Since they're being multiplied, we're going to divide this whole thing by t squared. If we do it to that side, we have to do it to this side. These cancel out. And we're left with just a. And so 2 times delta x minus x initial minus vit over t squared equals a. So let's plug in some numbers. So delta x equals 110, x initial equals 0, v initial equals 0, and t equals 5.21. But since it's being multiplied by 0, that doesn't matter. So this goes away, and this goes away. And we have to put that over 5.21 squared seconds. Alright, so I am going to punch that into my calculator. Get rid of this just so it doesn't confuse you. And so I have 220, which is 2 times 110, divided by 5.21 times 5.21, because it's squared. So when it's squared, it's multiplied by itself. And I get 8.1. Where did my pen go? 8.1. And the units for acceleration are meters per second squared. So 8.1 meters per second squared. Let's see. 8.1 meters per second meters per second squared. So problem solved. End of lesson 2.